the road. You're right. Okay, so we'll go back over functions. Okay, I hope Audrey will catch up. So let me share my screen and go to, right. This is, let's see, function simplified. You see that? Oh, you see that, Latoya?
Yeah.
I see Chatsy is coming on. Functions, I hope this is going to be simplified. So functions have what? An input and an output. And it's the relationship between an input and an output. And actually, you know what? We've been doing functions, but we just didn't call them functions. When we said y equal to x plus b, that's a function. That's a linear function. We just write it as an dependent variable equals to a relationship with an independent variable. We just didn't call that function, but it really was a function. So it's just another way of writing it. Instead of saying y equals something or b equals something, we say function notation, f of a variable. So it's nothing new. It's just a different way of representing it. Latoya, is that making sense to you?
Yeah.
Yeah, it's just a different way of representing it. So because when we looked at linear functions, we had an input and we had an output, right? So let me just when we said y equal
X
mx
plus B.
plus b, that's really a function. I'll just put a small y. That's a function.
Um,
Yeah, the output is y, the input is x. Okay, so let's just put that. Output is y and input is x. All right, now we could write that as a function. Now we say y equal mx plus b. Now we could say f of y equal mx plus b. And all that's saying is the function of y output is equal to my input x. And m is, like we know, that's the slope or change in the value. And this being our constant or y-intercept. So instead of saying y equal mx plus b, we could say function notation, f of y equal mx plus b. So it's just another way of writing a relationship.
Good evening, Miss Barbara.
Hello, Audrey. I'm glad you're here. Because I know you had said you still having problems with function, and Latoya said she was having problems too. So I said we'll start back over and try to get this in a way you can understand it. So what I was saying is, you have been doing functions. We just didn't call them functions. Remember when we had the linear equation for the slope intercept, and we said y equal mx plus b. The output is y, the input is x, right? The x is the independent variable, the y is the dependent variable. In other words, the value of y is dependent upon x. So instead of saying y equal mx plus b, we say f of y equal mx plus b, where the input is x and the output is y. It's just a function notation, and it doesn't have to be a f. It could be a g, it could be a b, it could be a t. All right, but normally we use f, the function of a variable is related to a variable that is the independent variable. All right. So 3 things you must have in a function, and we have seen those before. We must have input, output, and a relationship. So input X, output Y, relationship, they related by multiplication and addition. M times X is multiplication, and then the addition of the constant. Okay. And over here, you see it in a nice little colorful diagram. Input X, function f of X, the input X, the Y is the output. Okay, that's using the X and Y, which we normally use when we use our graphs. We have the X coordinate and the Y coordinate. So classic way of writing a function is f of X, but you could say, well, because notice when you say f of X, you're saying the X is the input. So f of X.
So Miss Barbara, the X would go into the parentheses.
Yeah, the X would be f of X equal mx, but f of X is Y. So let me just put, yeah, the X would go here, not the Y, but the f of X is equivalent to Y. So we can say f of X is equal to what we've been calling Y. Okay.
Mhm.
So they're the same thing. It's just that it's a different way of noting it. So you've been looking at this all along, but we just didn't call it a function. We said it was what? A linear equation. And we had it with quadratic equations of functions, and exponential equations of functions, except we didn't express them as function of a variable. We just said Y or Z or B or T, etc. All right. So important thing to remember, function has 3 parts: input, output, relationship. So sometimes you're given a function and you ask, what is the value when I change my input to a value? So in the parentheses, you put what that input is, and then you calculate what your output is. Okay. Any questions so far?
When you say calculate the output, that would be the number
Calculate.
that comes-
Go ahead.
No, I was saying that would be the number that comes after the first part. Like
Well,
the FX.
well, the f of X is your output, which is equivalent to your Y when we had Y equal mx plus b. That's your output.
Oh.
The variable in parentheses is your input.
Oh, so the F is the output, or
F-
the G or whatever they put first.
Whatever that letter is, could be G of X, could be G of T, whatever. This is your output. In other words, this value f of X or Y or whatever I choose to call it is dependent upon this variable X. And I can substitute values in it, right? For instance, over here, you see where I say multiply by 2 is a simple function, right? So my input is 0. My relationship is a multiplication, and I multiply by, in my relationship, I'm multiplying by 2. My input is 0.
So where's the 2? So where's the 2?
Right here. I'm on the right side of the screen. You see right here?
The white, are you touching the Y?
Yes. Right. No, right here. Not here, but here. Okay.
Oh, I was on the wrong side there.
Yeah, you see, multiply it by 2. Very simple function. You see, you have input, relationship, output. There's your input. Your relationship is a multiplication by 2, and there's your output. So 2 times 0 is 0. 2 times 1 is 2. 2 times 7 is 14. 2 times 10 is 20. So once you know your relationship, you can put in values for your input and calculate your output. So you could calculate your output if this was a 20, right? Because it would just be 20 times 2 is the output of 40. Got it? So that's
Mhm.
why. So if my input was 50 here, Audrey, what would be my output?
50,
Yes, this is my input, 50. What would be the output?
50,
Input is 50.
right?
Relationship is multiplying by 2. What would
Oh,
be the
100,
output? What would it
100,
be? That's right.
100.
It'd just be input 50 multiplied by 2. That's my relationship, multiplication of 2.
I thought
And
input was where you have the 0.
yeah, this is the input right here. See, my inputs are what? 0, 1, 7, and 10. My outputs are 0, 2, 14, and 20. How did I get them? I multiply 2 times my input. So if my input is 50, 2 times 50 would be 100. So right
So
here, this,
whatever the relationship in the middle, you have to multiply it by what is in your input.
yeah, you apply the relationship to the input to get output. So if
Oh,
this is 50, let's put 50 here. Okay. And I multiply the 50 by 2, and I get my 100. This is still, let's see. We take the dots out because then we put what it is equal to when my input is 50. And it's still, the relationship is times 2, right? Times 2. Okay, so let me make this a small x. So I'm multiplying this by 2. The input times 2 gives me the output. So you have your 3 parts. You have your input, your relationship, and your output. And we've been doing that. You just didn't call it a function. We called it the kind of equation it was. It was linear, that we know we graph, we get a straight line. Or if it was quadratic, we had at least a square, right? We had something raised to the second power, and that was quadratic relationship that we could say quadratic function. Or we had an exponential where the power is the variable. All right. All right. So functions is no different than what we, except it's no different from what we've been doing, except we're expressing it a different way. So think it as I've got an input, and sometimes they picture it as a machine. You put in input and you do something that you call a relationship to the input, and then you get output. Okay, that's true of a function. All right, that's the structure of it. The notation is when we use the variable of the f of the function, or the g of the function, or the h of the function. Okay. Audrey, is that clearer?
Yeah.
Okay, so that's a function right there. We multiply, we apply multiplication of 2 to our input to give us our
So
output.
does it always be multiplication?
No, it doesn't have to be multiplication. Remember, your relationship could be multiplication, division, subtraction, addition, or it could be a combination. You may be multiplying and adding. All right. Well, like over here, f of x is mx plus b for this linear function. We're multiplying and we're adding a constant, right? So it's a combination, but it's always addition, subtraction, multiplication, division. That makes up your relationship. It could be single, or it could be a combination. It could be division and addition as your relationship. Whatever relationship links your input to your output. And that's not always just one mathematical operation. It could be more than one mathematical operation. All right.
Okay.
Okay. So we say function notation. So function notation is just another way of representing the relationship. Y is the output. That's equal to f of x. Just put a space here. And we read this as f of x. It could be g of x, h of x, f of theta, g of u. And all these make up functions. G of x, x plus 1. H of x, 2x minus 7h. G of u, 2u squared minus 7u plus 3. Now notice what you put in parentheses is your input. So if you put values over here, say if this, let's just take this first one, Audrey. Latoya, I'm putting this as a 2. Now, G of 2 would be equal to what? Wherever you see an X, you put a 2. So G of X would be G of 2. That's my input. X, that's equal to X plus 1. So I put 2 plus 1, and that's
1.
equal to 3. All right.
Yeah.
Substitution of the input, apply the relationship, which is a plus, right? So 2x plus 1, this would be x plus 1, where x is now 2. And you know it's 2 because that's what's in your parentheses. That's the input. G of 2 equals 2 plus 1 equal 3. Got it? Audrey, is that clear?
She said G of 2 equals.
Wherever you see the variable x, you want to put a 2.
Okay.
So G
Yeah,
of
but-
x, if I'm trying to find G of 2, that's substitution, right? For the variable 2 for the x. So I put G
Yeah.
of 2, and my x is right here. And then I put 2 for the x. So G of 2 would be 2 plus 1 or equal to 3.
Yeah, okay, got it.
All right. Now take this one. Suppose this is h of x, right?
Mm-hmm.
So h of x, and my x is, we'll say a minus 3. So if h is a minus 3, if the input is a minus 3, what is the output? What would this be?
H of 3.
2 outside and x minus 3
Still-
for the x
What would it be, Latoya?
minus 6.
Okay, it would be 2 times the minus 3. That's right. Substitute that for the x, and minus 7h. So the answer would be 2 times a minus 3, minus times plus gives minus. So that would be minus 6 minus 7h. Now, it just so happens here that the h is a variable and the h over here represent a function, but that doesn't matter. You don't change this. This will just be minus 7h. So your answer would be minus 6 minus 7h. Questions? Is that clear?
Yeah,
Wherever-
kind of.
Wherever you see a x, what are you going to put? A minus 3. That's your input. You see there? That's why you put it with your function notation. H of minus 3 is 2. Now I have an x here, so I want to put a minus 3, and this remains 7h. Nothing to substitute there because it's not an x, right?
Hey, I'm sorry.
Hello.
I- Hi, how are
Are
how's
you, are you,
everybody?
are you driving or are you at home?
No, I'm at home. I'm watching actually. You said the X. I thought the X was supposed to be 2.
Yeah,
Why is
Well,
it a -3 there?
well,
She don't have
no,
a 3 though. She,
no, I
she's
had a 2 here, but my input now, I changed my
she changed it.
H. I changed this H where my X is a -3. I
Yeah.
changed the input to a new value.
Maybe 3
Are we allowed to do that?
was.
Yeah, you can make anything you want. These are examples.
Mm,
So
Mm,
I can say, okay, H of -3. I can say H of +3, H of 0.
oh,
And
wow.
wherever you see the X, I put the 0. So 2 times 0 is 0. 0 minus 7H. Answer would be -7H. You follow, Chastity? Whatever I put here as my input in my function is what I substitute for this.
The X?
Yeah, in this case, that's my independent variable.
Okay.
This is my output or my dependent variable. In other words, H of X output is dependent upon the input variable X. And here I'm assigning that X a -3. So wherever you
Okay.
see the X, you put a -3, do the calculation, and you get the H of a -3 is -6. 2 times 3 -6 plus time minus -7H. Is that clear?
Yeah.
Sort of.
Okay. All right. Now let's take this same function now, since you said sort of. Now suppose I gave you H of 4. So my input for X is 4. So that means wherever you see an X on that right-hand side, over here, you want to put a 4. So what would that be, Chastity? This would be 2 times what? I'm looking
2
at
times
this.
2.
No, what
Is
is
it 2
X?
times 2?
It's
No, my
4.
input is
4.
a 4. So that would be 2 times 4, right?
Yeah.
Minus 7H.
H.
And what's 2 times 4?
8
8. So that would be 8
minus
minus.
7H.
That's it. Very good. That's the answer. So whenever you're looking for the value of a function, you always put your input in the parentheses. This is output, right?
Okay.
Right here, this is output. So you put the input value here, substitute it into the variable, and then solve it. So H of 4 will be 2 times 4, because X is now 4, minus 7H.
Okay.
Questions? Okay, try this one. G of U is 2u squared minus 7u plus 3. Now let me put that here. Okay, now I want you to calculate. Okay, find the value of the function. Find, because this is the way it's usually worded. Find the value of the function when u equal 3. Okay, so I want you to calculate the value of this function when u is equal to 3. So that means wherever you see u, you're going to put a 3, right?
Yeah.
All right, so let me just copy this. And let me put a 3 right here for my input. Put a 3 here. Where else would you put a 3, Latoya?
where u square is u2.
Right, that's right. You put a 3
So
there,
that's
so you're
gonna
gonna be
be 18.
squared. So you're gonna be squaring a 3, right?
Yeah, it's gonna
Okay,
be 9 and 2, 18.
okay. And where else would I put a 3?
That is 7.
Yeah, right there I put a 3 because that's a U, right?
Yes, so it's gonna be 18
So what would be
minus
your answer?
21. 18 minus 21
So
plus
that would
3.
be equal to what?
18.
Okay,
Two.
2 times 9, because 3 times 3 is 3 times 3. 3 times 3 is 9. So that would be 2 times 9. And minus
Yes.
7 times 3 is a minus 21, right?
Yeah.
21 and plus
3.
3. So what's that equal to, Audrey?
Oh, 18.
What is that equal to?
Mm,
minus
6.
21 plus 3. What's that equal to?
18 minus 21.
Audrey, what is that equal to?
18. 18 minus 21 plus 3. That's what it is.
What is that equal to? This is G.
0.
That's right. You're absolutely right. It's 0. Because what? 18 and 3 is 21, and 21 minus 21 is equal to 0. So you get 21, a plus 21 and a minus 21, and that's equal to 0. Okay. So the function G of 3.
Bailey, what are you doing?
So 21 minus 21 equal 0. Questions? Questions on function notation?
Sorry about that. I'm cooking.
Okay. So when you see the F, it could also be a G, could be a H, could be a B. Just remember you have input,
Output
relationship,
and
output.
output.
Okay. The independent variable is what? Input or output?
What you say?
The independent variable.
Output.
Is the G?
The independent variable is input or output.
Output.
The output is the dependent.
Or independent.
Yeah, what you see over
input.
here is dependent. That's like your Y, right? That's dependent upon what you have over here on the right. So your independent variable is that variable that's on the right side, and your dependent is the one here on the left. So think of it like Y and X. The Y is output, the X is input, except your Y here is your G of U. Okay.
Mhm. You said the independent is on the right, and what is on the left?
Yeah, whenever you have it as an equality, right? Your independent variable is on your right side and your dependent is on the left. In other words, Y is dependent on X. So Y is the dependent variable. And Y, of course, could be a function, G of something, H of something, F of something, okay? Always put your input in your function. It makes it easier when you're calculating it. If, like, I have G of U, right? But when my U is 3, put that 3 where the U is. Then wherever you have U on the right, you put the 3. Okay, so if you're looking for G of 3, say G of 3. Don't leave it as G of U, because now you're making a substitution for this variable. Okay, and that substitution is the 3 for the u. Questions?
So what's the difference between the top one and this one?
What do you mean when you say top one?
Because
What?
the one with the 7H and this one.
This one?
Yeah.
Well, the difference is, well, notice this one has the variable squared and then it has the variable multiplied, right? So it's really
Mhm.
squared and multiplied, right? This one just has the variable with the 1 default raised to the 1 power. All right. And it didn't have a combination of adding and subtracting. The relationship,
Okay.
yeah, this one has multiplication, subtracting, adding. This one has multiplication and subtracting. So the relationship is varying, okay? But whatever it is, you're gonna apply the value of the variable that's given in your problem to the variable in the function. So h of 4, put the 4 on the u wherever it appears. That's the variable. That's why you say h of 4. Or if you say 3, g of 3. U appears here as u square, appears here as u. So you put that 3 wherever you see that u. It's a substitution, which we've been doing, except we didn't call it a function. And it was a function, but we didn't, it is a function, but we didn't call it a function. We just said it was an equation, right? Linear equation, quadratic equation, exponential equation. But it's a function. Function is just a different way of expressing it. We call that function notation, where instead of just saying variable equals something, we said f of a variable equals something. And we call it f of x if it's f of x. If it was g of a, we would say g of a. Okay.
Yeah.
Any questions? Now, here's a function, f of x equal x squared. Now, if I ask you, what's the value of this function when x is 9? What would you tell me, Latoya?
What is the value for?
What's the value of this function when x is equal to 9?
9 square
X, that's right.
is
When x
18.
is equal to 9,
9 square.
when x is equal to 9, then f of x,
81.
that's right, f of 9, and you square whatever that variable is, and that's equal to 9 times 9 or 81, right? So whatever that variable is, you just square it. So if x was 10, 10 squared would be 100. Okay, so that's the relationship. Relationship here is squaring the variable. So whatever that variable is, you square it. What if it was a -3? What would be the function?
A -9
-3 times a -3, Latoya?
or 9.
Yeah,
It's
that's right.
positive.
Positive. Like signs give you plus. Okay, so whether it's a +3 or -3, you get the value of the function equal to 9. All right. Input, relationship, output. Here the relationship is squaring the variable. Input, this is the output, input, relationship, squaring the variable. Okay, and just another example, the input is a 4, square root of 4, 16. So f of 4 is 16 because f of the variable, function of the variable, is the variable squared. So whichever number you put here for the substitution of the variable, you square it. All right. Now, X, we've been using X a lot, but that's just a placeholder. All right, that's just a placeholder because you can use any variable you want from A to Z. So for instance, f of X is 1 minus X plus X squared. We could have said f of Q. So instead of X, we say Q. Or we could have said H of A instead of X. We use an A as the variable. Or you could say U of N. Instead of F, you're saying instead of W of, well, instead of F, you use a W. Instead of X, you use an N. But notice you have the same relationship. You're subtracting and you're adding the square of the variable. So it's the same. So what are your variables? Whether they're a Q or A or N or X, it's the same. Because when you apply this, like f of 2, like here where the X is, you put a 2, where the X is, you put a 2. So 1 and X is the 2, and X squared is 2 squared, and that gives you 4 minus 2 is 2 plus 1 is 3. Questions? So we can change these variable names up. We can change the function name, and you apply it the same way. Because here, notice the relationship is the same. You're doing the same thing to the variables regardless of what you call them. Okay. So in just one sentence, when we have a function, we relate an input to an output. Now, let me give you an example here. Okay. A tree grows 20 centimeters every year. So the height of the tree is related to its age using the function h. So h, the age, is equal to the age times 20. So if the age is 10 and we put 10 for the age, and notice we said h of age, h of 10. For the age, we put 10, we multiply it by 20, and we get the height as 200 centimeters. Okay, is that clear about this function? What is the function, Latoya? What is the function?
H of age.
H of age, right?
H. Yeah.
What is the input?
10.
No,
20.
the input is the age.
Oh, the age. And the output is the 20.
Input is the age. The output is h of age. All right. See, if you have this formula, and that's the relationship, you apply that to that formula to the age, and you get the output. So if the age is 0, 0 times 20 is 20. So the function for h of age is 0. But if the age is 1, you'd have 1 times 20, and that would be 20. Is that clear?
Yeah.
There's the table, right? So if it's 20, you put the 20 for the age in the formula. 20 times 1, you have 20 times 1 is 20. All right. If the age is 3.2, you'd have 3.2 times 20, which is 64. All right. If the age was 15, you'd have 15 times 20, and that would be 300. Now, what if the age, let me put another value in the table. What if the age was 25? So I'm putting 25 here. Okay, that's the age. All right. Now, what would be the height of the tree, Audrey? This is 25. What would be the height of the tree?
Let's see what part you are. You left all right, because I ain't seeing.
Well, I'm over here. That's the end of the table. The age is now 25. I'm asking you here, what is the height of the tree? You have your formula. The height of the tree for a age, and this is 25, is
Mhm.
the age 25 times 20. What is 20 times 25?
20 times 25 is 400.
20 times 25,
500. Sorry.
500. That's right, 500. So that means the height would be 500, right? And that would be in centimeters. Okay, so if it's 25, the age of the tree, then 25 multiplied by 20 would give you 500, the height in centimeters of the tree. And we did that from the relationship. The H of 25 is 25 times 20. Questions? And that's all from the table that gives you the relationship. Now, functions have what we call special rules. That means, and you only have one relationship for every input value. So that means then that whatever's input, there's only one output for it. Okay. So you have the element of one set related to one element of another set. And that could be X and Y, it could be something else, right? But this is how you can identify whether something is a function or not. For every X, there's only one Y related to it, or for every input, there's only one output. Okay. Now, so we say that is single valued. In other words, f of 2 can't be two values, 7 or 9. That's right. That's not right. It has to be just one value. Now here's a mapping. And notice relationship x to x squared. Okay. Now we could write this as a table, but we have it as a map. So 3 square is what?
9.
That's right. And see, that maps to 9 right here.
Yeah.
1 square is what?
1.
And it maps to 1. 0 square is what?
0.
Right. Okay. 4 square is,
16.
and a minus 4 square is
16.
16. Now, is this a function?
What is that?
Is it a one-to-one of a input to an output? Or I ask you the question, do you
I
see
think it's
that?
1-to-1. I'm not sure.
Yeah. What would you say, Latoya? Is it a one-to-one relationship? Latoya?
The toilet, she's sleeping.
Oh, she might be signing out. Okay, Audrey, you're exactly correct, because there's only one input to an output. In other words, 3. And the way you know that, because you look on the left side for the X's, right? And if you see a duplicate X, then you know it's not a one-to-one. But every X is different. Let's see, 3, 1, 0, 4, minus 4. Because a minus 4 is not the same as a 4.
Right.
Right?
Mhm.
So this relationship represents a function because every input maps to one output. If it mapped to more than one, then it would not be a function. And you could write this as a table. Now there it is as a map. Okay, and we could do it as a table, and as a table, you can see it also. Here are your X values: 3, 1, 0, 4, minus 4, 9, 1, 0, 16, 16. And if we had a 5 here, 5 squared would be 25. So every element of X is related to a Y. So every input should be related to an output, and no
How are
X
you?
value should have,
I'm good. I'm in a class. Can I call you back? All right.
okay, so it's a function because, and notice why it's a function, and and make sure you understand this, okay? Every element in X is related to a Y. Notice every element is related to a Y, right? No element in X has two or more relationships. And that's true because you only see the X value once. Now, if I had 4 here again and try to map it to something else, then it wouldn't be a function. But notice my input here only appears once. So it's a 1-to-1 relationship, never 1 or say 2 X's, same value linking to an output. So the 4 and the -4 are different. Now, let's look here at another one, see if you can. Okay. Now look at this. I'm over here on the right.
Mhm.
Now I say this is not a function. And do you know why? Or why is it not a function? There are actually 2 or 3 things that make it not a function. Just give me one of them. One of the reasons you think it's not a function.
Because the X and the Y doesn't have a relationship. I don't know.
Well, that you're right. The X, yeah, 3 is not mapped to a Y, and 4 is not mapped to a Y. Okay, so 3 is not showing a relationship to Y and 4. And there's another reason. The 5 is mapped to 3 different Y's. So that makes it, see, it has more than one value. So 5 is mapped to a 4, 5 is mapped to a 5, 5 is mapped to a 7. Okay, so that makes it not a function. Now, the fact that 6 is not mapped to anything is not a problem because it's not the Y's we're looking at. We're looking at the X's. So it doesn't matter about this Y not being mapped to an X, but it does matter that the X values be mapped to a Y. Is that clear, Audrey? Okay, so in the mapping, you can see what's not mapped to anything, 3 and 4. You don't see any lines of 3 and 4 to a Y value. All right. And then you see 5 actually mapped to 3 different Y values. So even if 3 and 4 were mapped to values, this wouldn't be a function because 5 is mapped to 3 different Y values, and it can only be one Y value. Okay. All right. So that's very important to be able to recognize functions either from a map or from a table, okay, or from a graph. Now, you've heard of domain and range, right? Now, domain is the independent variable. So that's what we've been saying, Y and X, that's the X value. The range is the Y values, dependent variable. In other words, the Y value is dependent upon the input, and that's your output. And the relationship is between the input and the output. Okay, so if you were given X and Y pairs, you'd pick out the domain as all of the X values and the range as all of the Y values. Is that clear? Any questions? Domain. Go ahead, Audrey.
You said the domain is the input value?
The domain is the X values are input, right? So when we're using Y and X, like on the coordinate grids, that would the domain would be the X values. The range would be the Y values. Now I'm using this as on the coordinate grid where you have the X, the horizontal, and the Y, the vertical. So that represents the Y values. And you know, ordered pairs is that for every X should be paired with a Y. So if you were given ordered pairs, you could pick out the X values because they occur first, and then the Y values. So that means you can pick out the domain and you can pick out the range. Okay. Now, to make sure you know how to do that, let me just put some ordered pairs here. 1, 3. All right. And let me put, okay. And I'll put 3 minus 5. Okay. And let me put 4. Okay, these are ordered pairs, so which means it's X, Y, X, Y. 4, 7. Right. And put one more. 5, 9. And then I ask you, okay, these are ordered pairs, which means they are in order as X and Y. So let me put a space here. So that means these ordered pairs, and I'm saying ordered pairs. Ordered pairs, or they are in order. X come first, then followed by Y. Okay, Audrey, what are the domain of these ordered pairs? What is the domain of these ordered pairs? Okay, I'm bringing it down some, so, okay. Domain is the X values, right?
Yeah.
Yeah, all right. So I'm asking you the domain of the ordered pairs. What is the domain? What would you tell me? What are the values? The domain is the X values. So what are they?
1, 3, 4,
1, 3,
4,
4.
and 5.
That's right. That's the domain because that makes up what? The X values.
Value.
Yeah. X, Y, X, Y, X, Y, X, Y. Now I ask you the range. Range is the Y values. Range of the ordered pairs. What would you tell me?
3.
Okay, so that would be 3. Okay. 3, 5,
7,
7,
and 9.
and I say no. So where's the mistake? You made one error. Where's the error?
3, 5, 7. Oh, the 5.
So what is the sign on the 5?
X.
No, the sign.
The sign is the X value.
No, the sign on the 5 is a plus or minus.
Oh, it's a plus sign.
Right here. Range is the Y values.
Oh, it's a minus.
It's a minus. That's
Minus
right.
5. I didn't see that.
Yeah, it's a
-5.
minus 5. So the range of the Y values, that's 3, minus
Minus
5, 7,
and
and
nine.
9. So that means with an ordered pairs, you can identify the domain, you can identify the range. The domain are the X values, the range is the Y values, okay?
Mhm.
Questions?
No.
So that means the range, which is the Y values, that's the independent variable. Whereas the domain is the X values, that's the independent variables, okay? And here's an example. Z equals 2u to the third. The output, that's Z, that's the dependent variable. It depends on this input value of u. So u is the independent variable and Z is the dependent variable. Questions?
Okay, it says U is the independent.
Yeah, u is independent. Z, look at it this way. You see this on the left side? This left side Z is dependent upon the variable u. So the Z output is dependent upon the input u. U being the independent variable that affects my output variable Z, which is my dependent. So Z is dependent upon the value of u. All right. So if u was a 1, Z would be a 2, because 1 cubed
One.
is 1 times 1 times 1. So that would be 2. But if u was a 2, that would be 2 times 2 times 2, which is 8 times 2 is 16. Z would be 16. So our value of Z depends on the value of u.
U. Okay.
Okay. And that's what it says here. Dependent variable, it depends on the value of u. Questions?
No.
Now, ordered pairs, I said X and Y, right? But remember, my output could be a function. So instead of X and Y, I can say f of X. And notice here, I'm using f of X equal Y, okay? And that's exactly what it is. So for the function, no different from what we've been doing, except instead of saying the Y is the dependent variable or output, we're saying f of X or g of X or h of X. So if you had 4, 16, the function takes in the input of a 4 and it gives the output of a 16. So that means you square this and you get 16.
So wait, getting 16. How you get the 16?
No, I said the function takes in a 4. That's my input, right? And it gives out 16. To go from 4 to 16, what is the relationship? How could you go from 4 to 16?
You multiply.
Yeah, you could multiply 4 times 4, and 4 times 4 is 4 squared, right? So you
Right,
can
yeah.
square the 4
Okay.
and get the output.
Okay.
All right. So that's the relationship. Square the input to get the output.
So then you have the X, how you have it here, the X and comma, and then the FX.
Yeah, I have, see, this is an ordered pair. X, Y, right? But see, f of X is really the same as Y.
Right.
That's why I have the double
So
parentheses.
and it was getting confused too if that won't work, because when I get it then I didn't understand. Wait, have 2 parentheses.
Yeah, because right here, you have 2 because you have a paren here and a paren here to represent the ordered pair. And you have the paren here to represent the input of the function. Okay, so that's
So
why
what you do first? So which is do first?
What do you mean, what do you do first?
If you have 2 numbers.
Well, this is just an ordered pair.
Oh.
This is just an ordered pair. And I gave you numbers to represent it. So if this is a 4 and the output is really 16. So how did this become a 16? Because I applied the squaring of my input. So x to the squared gives me f of x.
Oh,
Okay. X raised to the second power gives me f of x.
so that means the x, that x to the f will be 4.
No, the x would be
Here,
4
that, this one.
and the f of x would be the function, but my relationship would be to square the x to get my output.
fx. Okay.
Yeah. So if this was, let's see, if this was 6, 36, right? So I take in a 6 and I get a 36. How can I go from 6 to 36? Audrey, what operation?
Multiply
Multiply what?
6 by 6.
Yeah, 6 by 6, which is 6 squared.
Square.
So if I
Okay.
square the 6, I get the
Mhm.
36. Just like if I had 7 and 49. I square my 7 and I get my 49. Okay, so that's my output is the 49. My input is my 7. My relationship is to square the variable. Okay,
Miss Barbara,
yes.
is it possible you could send me this and the previous class by mail? Not
Yes,
the class, this, you know.
I can print it and mail it to you. Do I have your
Because-
address?
Yeah, you have it.
Okay,
You
yeah,
send
I
me,
can,
you send it to me once because
Yeah,
my printer broke down.
okay,
Thank
All
you
right.
so much.
all right, let me make a note of it. Add a mail to Chastity. 11/22 session. Okay. All right. Now, this is doing something we just went over, Audrey. So there are the pairs 2, 4, 3, 5, 7, 3. So 2 is related to 4, 3 is related to 5, 7 is related to 3. So the domain, there are your x values, 2, 3, 7. Output values, the range, 4, 5, 3. Okay. So this is repeating what we just went over, where we said the x values represent the domain. That's the first value in the ordered pairs. And the second value is the range or the output values. Okay, 4, 5, and 3. And like I say, they're called ordered pairs because they always in the same order. You never have y, x. It's always x, y. Okay.
Mhm.
All right. Now, is this a function? These ordered pairs, do they make up a function, Audrey? 2, 4, 2,
Where you
5,
at?
7, 3. Over here on the left, on my left,
On the left. Okay, on the left. No, that's the right. Okay.
right over here, I have
Okay.
my ordered pairs are 2, 4, 2, 5, 7, 3. Would you say these ordered pairs represent a function?
Mm,
Remember, I can only have my x value only once related to a y value. It's not a function because C2,
because you have two have
that's right, 2 appears
two
twice.
appear twice.
Once mapped to a 4, the other one
Mhm.
mapped to a 5. So it
Mhm.
can't be mapped to 4 or 5. So
Mhm.
it's not a function. It has to be single value. In other words, my input can only appear once in this set of ordered pairs. If it appears twice, then it's not a function. Okay,
Yeah.
it's not a function. So just to kind of summarize here, a function relates inputs to outputs. Now, that means every relation is not a function, right? But every
Mhm.
function is a relation. But every
Okay, let me get that
relation,
again.
okay,
You said every
every relation is not a function, but every function is a relation.
okay.
Okay, and because like here we have these ordered pairs, right? That's a relation, but it's not a function because you have the same value for your X in your ordered pairs. And here's this 2 related to 2 different Y's. So it's a relation, and it shows a relationship between X and Y, but it's not a function.
Mhm.
So a function is a relation, but not every relation is a function. And that's evident by what we put here. This is a relation, but it's not a function. Okay, so a function take elements from a set. We call that the domain. That's the X, relates them to elements in the set, and all the outputs related are called the range. Okay, so relates them in a set, and that's the relationship you show there. It could be plus, minus, whatever. A function, special type of relation, every element in the domain is included. So if you have XY pairs, you have to include all of the elements in the domain. In other words, all the X values, and they only produce one output. So if you have XY pairs and not every input has a matching output, then it's not a function. And the ordered pair is the input and its matching output. So a function, a set of ordered pairs, a set of ordered pairs. Okay.
Yes.
Now, independent variables, dependent variables. Y equal f of x. Remember I said we've been using y, but now we're using function notation f of x. And that's equal to the variable square. So y is f of x, that's dependent on the value of x. And we can see that in the table. Y equal x. Y, z equals z, y, let's see, this should be a 2, I think. Okay, 2, okay. Well, we just identifying that dependent variable and independent variable. Notice the dependent variable is always, like I said, the one on the left. Y, dependent variable, dependent upon X, the independent variable. Z, the dependent variable, dependent upon the independent variable Y. Z is the dependent variable dependent upon the independent variable U. Okay, so this is a 3 raised to the 3rd power, and this actually is a y to the 2nd power. So let me just put that there. Just put that up. Let me move that over and put the y square. This is okay. So let's just put the square. That should be y square. Okay, so 2. Okay. Just take out the 2 here because that's y to the 2nd power, which is y square plus 2. That over some, okay, plus 2. Okay, so notice in all cases, your dependent variable is that variable you see on the left. Y is dependent upon X. Z is dependent upon Y. Z is dependent upon U, because U is what you see over here on the right. Okay,
Mhm.
so if you know the value of U, you can calculate the function, right? Because if you know U, say if U is 2, 2 times 2 times 2 is what? 8.
4 times 2.
And then 8 times 2 is 16. So that would be 16 as your Z. So you can plug in values for your independent variable and calculate the value of your function. Okay.
Okay.
Now take this one, Z equal Y squared plus what? I want you to take this function. I'll put it down here by itself. Okay. What is the value of this function when Y equal minus 8? Okay, what is the value of this function? In other words, what is Z equal to? Z
Minus
equal,
8.
what is Z equal to? What is it, Audrey? What is Z equal to?
Z equals to, wait a minute, it says Z is equal to Y squared.
Yeah, Y squared plus 1. So what's the value of this function? In other words, what is Z equal to?
8. Negative 8.
How are you getting negative 8?
You say the Y function is 8, negative 8.
Well, Y is, this should be equal. Y equal negative 8. What is the value of Z? What is the function, the value of the function when Y is a negative 8? Wherever you see Y, you want to put a negative 8. So Audrey, what's a negative 8 times a negative 8?
Negative times 8 is 64. Negative 8 is negative 64.
A negative
Negative is
8,
positive. Positive.
yeah, because minus times minus gives you
Yes,
plus,
it's a
right?
positive. Yeah.
So that's going to be equal to what?
64 times 1 plus 1.
So that's going to be a minus 8 squared for the Y, right? So let's just put the minus 8 for the Y, right? And what's a minus 8 times a minus 8?
0.
No, minus 8 times a minus 8.
Oh.
Multiplication, not that.
Yes, exactly.
What's a minus 8 times a minus 8?
64.
64, right? So that would be 64 plus 1. And what's that equal to?
65.
65. So wherever you see that Y, you want to put a minus 8, Audrey. So I put a minus 8. So instead of
Right.
squaring the Y, I squared the substitution for the Y, the minus 8. So minus 8 times minus 8 is 64. Then add the 1 because that's part of the function. And 64 plus 1 is 65. So you can see there where Z is dependent upon what? The value of Y. And my Y is the one that we're varying here. That was a minus 8.
Okay.
What if Y is 0? Audrey, what is y is 0? What is z?
0. Oh. 0.
Mental math. What's the value of z when y is 0?
0.
What is it?
0.
No. Y is 0.
What is 0?
Okay. Y equal 0. So when y is 0, what is z? What is z?
It's 1.
It's 1. That's right. 0 times 0 is 0. So y would be equal to, z is equal to 1. Z is equal to 1 because 0 times 0 is 0 and 0 plus 1 is 1. So it's just substituting in for the variable, except you're doing it here in a function. All right. Now I said z equals, I could have said what? How else could I have shown this? I could have said f of u equal z, right? Like here, I could have said f of u equals z equals 2u to the third. So it's what we've been doing all the time, except function notation is a different way of representing the equation. Okay. All right, let's look at our next screen. Okay. All right. Write an expression to represent the function from the following table of values. Now, Audrey, I want you to look at X and Y. Latoya disappeared. Latoya. I don't know if she's up.
No, I'm here.
Oh, you are? Okay, well.
Yeah.
Solve number 1. You and Audrey, solve number 1. Write it. Which one of these equations? This is a multiple choice. You have a table of X and Y values. Now write an equation to represent the function from this table of values. How is X and Y related? Y is the output, X is the input. What do you have to apply to X? What relationship is there between X and Y to get these Y values? Which one is it?
D.
You're saying D?
I said C.
You're saying C?
No, I said A. My first choice was A. I'm going back to my first choice.
You said A?
Yeah, I said A. A was my first choice.
Okay. Now, Latoya.
I'm not good at function. No matter how I'm trying to get this thing, I'm not getting it. It's not registering nowhere. I don't know why.
Now, Latoya, you said Y equal minus 2X, right? Now, when you put a minus 2 for X.
Which one are we doing? Is the circle?
We're doing number 1, the
was
table.
The wrong thing. I'm sorry.
We're doing table, not the mapping.
I was over the other side.
Okay.
That's why.
All right, we're doing number 1, the table.
So you didn't tell me you switch over, that's why.
Okay, sorry about that. Okay, number 1, you have a table. You have X values, Y values. Right? which equation represent the function from this following table of values? In other words, what relationship is there between the X and the Y? Which one of these is correct?
2 and
B,
2.
Which one you say, Latoya?
B as in boy.
You said B, Y equals 2X. Which one did you say, Audrey?
I said D. I don't know if I'm right, but
You said D?
mm-hmm.
In other words, you take X and you add 2 and you'll get Y? A -2 and a +2 gives you what, Audrey?
Oh gosh.
I just say, oh God.
A -2 and a +2, Audrey, gives you what?
Yeah.
What's a -2 and a +2, Audrey?
God. This
It's
math.
0.
So it's a 0 and it's
Yeah.
not a -4.
Mm,
So you
Oh.
know it can't be D.
Mm-mm.
God help us.
Oh,
Latoya,
God.
you've got it right.
I just guessed. I think I told you. You could give me multiple choice.
Latoya said B, right? She said
Yeah,
Y
B.
equal to X. And that's the answer. Because what? What's 2 times a -2? Audrey, what's 2 times a -2?
Oh, God, that help me here.
Audrey, what's 2 times a -2?
Oh, boy. All right, let me see. 2 times -2. Let me go put the calculator because I don't know that.
You don't have to do that. This is mental math, Audrey. I know you didn't say calculator. 2
It's a sign we mess up people.
times a -2. What's that equal to, Audrey?
A 0?
No, multiplication.
You said minus. You didn't say times 2. You said 2 minus 2.
I said 2 times a -2. Right here. 2x says 2 times x. X is a -2. What's 2 times a -2? Audrey?
-2 is -4.
Plus or minus?
4 plus or minus?
No, you said a 4. Is that 4 is a
Minus
+4 or -4?
-4.
That's right, -4. So 2 times a -2 is a -4. That's correct. Now, what's 2 times a -1?
It's a -2.
That's right, -2. Isn't that what you have in the table?
Yeah.
-2. What's 2 times 0?
0.
0. That's what you have. What's 2 times 1?
It's 2.
And what's 2 times 2?
4.
So the Latoya is correct, right? Answer B. You follow? You have to apply the input to the equation and get whatever's in the table for the output. And that only
You have to
happens.
multiply- you have to multiply the x by the y.
No. When it says y equal 2x, that means whatever's in the table for x, you multiply by 2, and you should get what you have over here for the y.
Oh,
And that only happens with B, because y equal 2x means to take the x, 2 times a -2 is a -4. 2 times a -1 is a -2.
so you're saying that whatever is in the x value, you multiply by what, 2
By
all the
the-
time?
by the
all the
2. By the 2 right here,
Yeah.
because the relationship says y equals 2 times the value of x. So if I take my x values and multiply them by 2, I should get what you see over here in the table for your y values. And that happens for all these values of x. 2 times a minus 2 is a minus 4. 2 times a minus 1 is a minus 1.
So what I'm asking, suppose you have a 3 now, you have to multiply whatever is on the y side by 3.
If this was 3x, you mean if this said y equal 3x? When you
No, but
said
I, no,
3,
so give me that. How do you do it without having the answer there? How do you know to multiply by 2? That's what I mean.
oh,
But
well,
if you're, hi, Miss Barbara,
yes. Yes,
I'm
Yes.
going to leave you to host the meeting now, okay?
okay. All right,
All right.
okay. No, if I didn't have these answers here, how would I know what the relationship was?
Mm-hmm.
Okay, well, for one thing, if these values, well, they're not all higher, but this one is well, absolute value is higher than this one. So that tells me it's a multiplication. Okay, so if that's telling me a multiplication, then I know it's between A and B. All right. See, if I didn't have these answers here,
Years ago, when I used to go to Canberra, they used to give you something like subtraction too. You used to have this from that and that from the other.
yeah, it could have been a subtraction. This is not a subtraction. Yeah, well, the reason if I didn't have these answers and I just had this table, I would look at my X values and my Y values and see if I can find the relationship. So I'm looking here, I say 2 and 4, that's 2 times that. 2 and 1, that's 2 times
that's what I
that.
wanted to
That's,
know. That's what
yeah,
confusing.
right.
Yeah.
Okay, so I'm looking at this and I'm saying, oh, if I multiply by 2, even this one, right? If I multiply by 2, because I know if I add them, I'm not going to get these values, right? Not, but I'd have to add them to something, right? But if I just say take a 2, like you said, a 2, but a 2, a plus 2 and a minus 2 give me 0. So right away, I know that's not correct. If I take the 1 and add the 1 and a minus 2, I get a minus 1. And I said, that's not correct. So it can't be my addition. It has to be a multiplication. So if I try the first one and I said,
so you're trying to say that you must always look at the answers to know if it's multiplication or subtraction or division?
yeah, well, you can look without looking at the answers, you can tell that you can eliminate it being addition, subtraction. It has to be a multiplication, because if you look at all of these, there's a multiple of 2, right? 2 times 2, 2 times 1, 2 times 0, 2 times minus 1, 2 times minus 2. So that tells me it's a multiplication. So I said, well, it can't be the negative, because a negative times a negative will give me a positive 4. So it can't be A, because this is a negative 4. Okay. So that means it has to be 2x. Answer B. Got it?
Okay.
Okay. Now that was from a table. Now, the next one, Latoya, that's the one, which of these is not a function? Now, this is from a mapping. Now, Audrey, what we said about mapping, we must have what? 1-to-1 for X and Y, right? If you have X and Y mapping to more than one Y, then it's not a function. Now, this is asking you, which of these following relations is not a function?
Okay.
Which is not a function? In other words, the X can only be mapped to one Y. Say if these are the X's, these are the Y's. And X can only be mapped to one Y. If it's mapped to more than one, it's not a function. So which of these, A, B, C, D, would you say is not a function? Audrey, which one?
Okay, just a minute. Just Okay.
Which one of the following relations is not a function? If you see a value over here, that's the X, and it's mapped to more than one Y value, then it's not a function.
Okay, so that's A.
Which one would you say?
A.
But A has a 1 mapped to a 1, a 2 mapped to a 4, and a 3 mapped to a 9. That's a function.
It's D. It's D, Miss Baba.
Which one do you say?
D as in
Yeah, sure.
dog.
Why did you say D? Latoya, why did you say D?
Because
The
Because-
one, on the 12, that's right. The one on the 12 doesn't match to anything.
Now, I want to know
2
why,
to 4.
why did you say D, Latoya?
Because 2 to 4, 3 to 9, but 4 to what?
4 to 9. And that's
Yeah, 4
okay.
to 9.
That's okay. 3 and 4 are different. They can map to the same.
No, 3, 4 is 12. 3, 3 is 9.
What? No,
Three
this is just
trees
a
is
this is just a mapping.
Oh, I'm
3
thinking
to
that
the
4 times 3,
9
12.
and
It's
4 to the 9. No, you
No,
don't
it's,
multiply. No, this
It's
is just,
B. Sorry, it's B.
why is it B?
You say it's not a function.
Yes, it's not a function. So you said B. Why do you say B, Latoya?
Because B is the right answer.
Why?
I don't know.
Not good enough. I want an explanation,
I
Latoya.
don't know.
Explanation.
You know the
No,
function
B,
is not
no, B
written.
is correct. Audrey, why is B correct? Audrey can tell you. Audrey, why is B correct?
Because the one is connected to the Y function.
To 2Y.
2Y, sorry.
Right. Yeah. See, the 1 is mapped to 2Y. So that means it's not a function because it should be a 1-to-1. 1 is mapped to 1, 1 is mapped to 2. 2 is mapped to 3, and 2 is mapped to 4. So it can't be a function because this X value is mapped to more than one Y value. Got it, Latoya? That's how you explain it. Remember, I said it's only a 1-to-1. In other words, 1 can only be mapped to 1 Y, not 2. 2 is mapped to 2 Ys, can only be 1. Okay. How could I make this a function, Audrey? What could I do in the mapping to make B a function? Just tell me in words. Yeah. How could I make B a function? More than one way, more than one answer.
Because you have to have 2 of the same domain, or
This is not a function, but how could I make it a function? There's more than one answer.
input value would have to have the same input value.
No, there's a couple of ways I could do it. I could take this mapping out from 1 to 2, right? And I could take the mapping out 2 to 4. Then it's a 1-to-1. That's one way of doing it. Or I could put some more X values here and make them different values. In other words, I could put a 3 and map it to a 2 and take the 2 mapping out. I could put a 4 here and map it to a 4, right? And that way it's a 1-to-1. Okay, so that's ways you could make that a function, because there should be an X mapped to 1 Y. So this is right. This is really like like one appearing twice over here, mapped to two different Y's. Two appearing twice and mapped to two different Y's. Okay. So that's how you could make it a function by mapping a 1-to-1, every X having its own Y, not two or more, then it's not a function. Okay, let's go. Any questions on the mapping? And notice now your 1 here and your 12 didn't have anything mapped to it. Those are Y's, so that doesn't matter. So that does not take it not being a function, because every Y doesn't have to map to an X, but every X must map to a single Y. Okay. All right. Okay. Look at this number 3. Okay. The function F is a function from A to the set of whole numbers as defined in the table. All right. What is the domain of F? Now, what did we say the domain was? Domain was what values? X or Y?
Domain was X.
Yes,
The
the
domain
domain
is
is
the
the X
X.
value. So what is the domain, Latoya? What is the,
Yeah.
it's
Oh
the X,
God, that's all I remember.
it's the X value. So what are the X values? All you did
3,
minus,
two.
no, -3.
yeah,
minus three.
-3,
What's the next one?
-1,
-2.
-2. Don't forget the 2, Audrey. -2.
Oh.
What's the next one?
-1.
-1,
0.
0,
1.
1,
2.
2,
3.
3. That's it.
Mhm.
Domain is just look in your table, all your X values. F is a function from A, but notice A has what? -3, -2, -1, 0, 1, 2, 3. And those are your X values. So that's your domain. Questions?
No.
Any questions on number 3?
Miss Barbara, you
Yes.
know when you see where you spot to plot the thing in? Could you send me a few of that, because I think sometimes I get confused still.
What?
Like the one where said G of X and you put like 2x plus 5 or something like that.
Yeah.
Yeah,
Me
I
too,
want to learn
please.
to plot in better, because
Which,
I don't
which,
think I really understand it deeply.
which one is that?
You know the ones that where you were doing, or you put in the F of
FX. You come with the FX, then you put the G for the numbers for the F, so the
yeah, you put
for the Y value.
yeah.
I mean for the X value. You know, sometimes you put a G, say you say G of Fx equals to 0. I mean equals to -8 or something like that. So you will put the 8 into the X, where the X would be.
Was
Yeah,
this
but
something we went over earlier?
Yes, yes.
yeah.
Tell me when I get to it. Okay. I have
Something like this one.
like
Like the one
G.
with the 7H and stuff. Yeah, like
Oh,
you know,
like here.
U. Yeah.
Oh,
But you
okay.
put the number in there.
Okay. Yeah, I said
The
G of
notation of something.
It smells.
like this one.
Límpiale el oído, because I think that's why he's.
Yeah,
ears
something
smell.
like that.
Okay.
Because I think
You bought a
I
Coke?
need to grasp it
You bought a
better.
Coke?
Okay.
Yeah.
Well, this one we have. I had some examples of functions: G of X, H of X, G of U, right? Now,
Yes.
H of X, I said, when H is 4, well, let's just take this one. h of x when x is a -3. So wherever there's an x, there's a -3. So I said h of -3, 2 times x. That x will be substituted by -3. So
Yeah, something like that, like when H is 3. I don't
yeah,
know how to explain
yeah,
it.
H of
okay.
x, I could say, which is
Well, h of x,
is
where
equals to
x is a -3. So wherever you see an x, Latoya, you want to put a -3.
-3.
So that would be h of -3 is 2. And now for the x, I put -3. 2 times -3 minus 7h. Multiply 2 times -3, get -6. And then just write in my minus 7h. So h of -3 is -6 minus 7h. Is that clear, Latoya?
Yeah, no, sir, I wanted some to practice.
Oh, you want some? Okay, so let me make a
Yeah,
note.
like these ones, I
Okay,
wanted to practice it better to get it really down packed.
okay,
Me too, please.
Yeah,
okay.
'cause
I'll put that as your
sometimes I'm
homework.
mixing up the sign or something. I'm doing
Okay,
something
homeworks
wrong.
and practice of functions. And this is all substitution.
Yeah,
Okay, this will be all substitution. So I'll send you about 5 problems for your homework to work on that, okay?
okay.
All
So you
right.
gotta put it when x is -3. and
Yeah, I will give you the
-2.
function and I will say, what is the value of the function when the variable is -4, say, whatever. I'll give you some that are squared, the variable squared. I'll give you some where it's addition, multiplication, or addition, subtraction, combination. Okay, and then you substitute in the variable and give me the value of the function. All right.
Okay.
Okay. Now, where were we? We were looking at,
The domain.
okay. And domain is x values and the range is the y values. Okay, let's go to, okay, we did the mapping. Okay, you gave me the right domain, the x values. Now, number 4 is a graph.
Ooh.
Okay, which one of these does not represent a function?
These 3 are for them.
It's 4.
Mm.
There's one, this is,
My phone is small, that's
increasing.
why.
Okay, let me just let me bring that down. Okay. Now, is it A, B, C, or D? Which one of these does not illustrate a function? In other words, which one of these lines show you an X value with different Y values? Which one would you say?
See?
That's right. Very good. That's C. Because there's X, but notice you've got all these Y values. So whenever you have a vertical line, it's not a function, right? Because your X value is the same, but your Y values are changing, right? So this would be, your X value is the same. So what kind of what would you call that? You're dividing by 0 because your X value is the same. So that would be an undefined. The slope of this line is undefined. So whenever you have a vertical, you have an undefined slope. So which graph does not illustrate a function? Just like Latoya said, it would be C. Answer C. What about if it was a horizontal line? What kind of slope? If it was just a horizontal line.
Unilateral, what's her name?
Horizontal?
No, it's not parabola. It's the other one.
No, you just have a horizontal line. If you had a horizontal line, that means your Y values are the same. So a horizontal line, your slope is what? Y diff
That's what you're writing.
over left over X difference. Right? The difference in Y over the difference in X. So if your Y difference is the same, then you'll have 0, right? So your slope is going to be 0 divided by a number. So your slope is 0. So for a horizontal line, your slope is 0. For a vertical, your slope is undefined because you're trying to divide by 0. All right, and that does not represent a function when you have your values all the same for the X with different Y's. That's not a function. Okay.
Okay.
Questions?
Is division that there is divide? Why divide difference or divide by X over difference?
Yeah, that's a division.
Oh,
Yeah. Mhm.
I open and print it out, it come up bright.
Yeah, that's let me just do it this way. Slope equal Y difference. And let's just put it over. And that's divided by the X difference. Y difference divided by X difference, okay? Okay. And your Y difference, if the Y's are the same, your Y's will be the same. So that means Y1 minus, well, Y2 minus Y1, whichever you label it, will be 0. So 0 divided by a number will give you 0. Okay, but if you're trying to divide by 0, you get undefined. So vertical, undefined, horizontal, slope 0. Okay, the very last one. See if you can solve this one. The function, can you see that one?
Yeah.
Okay. It's defined on the real numbers by f of x is 2 plus x minus x squared. What is f of minus 3? That means wherever you see a minus 3, you want to put what? Wherever you see a x, you want to put a minus 3. So there's the function. Substitute the minus 3. Tell me what value you get.
Oops,
Okay.
you pass it.
All right.
Let's see. 9, 2, 6, 6.
Can you scroll down a little bit, please?
Okay.
I can't see.
Okay, I'm going to put it on the other side. Okay, is that better? It's over on the right side.
Yes, thank you.
Okay. Now I want you to calculate f of minus 3. Calculate f of minus 3. Okay. So wherever you see the x, you want to put a minus 3. And tell me what you get. It's the very last problem.
B, Miss Barbara?
Any other answers? You're going to put a minus 3. Minus 3, okay. For the x, and the minus 3. I'll just put that in parentheses. And that minus 3 is squared. Now, Latoya, you said you got B.
Yeah.
Audrey, what did you get?
Oh,
I just- oh, good, oh, gee.
Okay,
see,
now
this-
it's just the math now.
Mm.
Okay, wait a minute. 3,
So
3.
plus or minus 3 is just a minus 3, right?
Mm.
2 minus.
And what's a
3.
minus 3 times a minus 3, Audrey?
Minus 3 times a minus 3
Is what?
is 9, right?
Okay, so that's a 9 plus
Right.
9. So
9,
let's just put 9 here.
right? That's why I got that.
Okay, let's take out the square.
Minus, and then you got a minus.
Okay. So I take this paren out because I said plus minus gives you minus, right?
Okay.
I can take this 9 out. Minus times minus is plus and minus gives minus. So that would be minus. So what's the answer, Latoya?
Minus
B
3.
minus 4.
How did you get minus 4?
Because I
Two.
said 9.
Is
I
1,
said,
that's it.
2 plus
minus
3,
3.
5. 5 minus 9, 9 it give
That's
you a
not a
minus 9.
plus 3, that's a minus 3.
Minus 3.
Oh.
Oh,
Stupid.
what did
It's
you
a
get,
minus-
Audrey?
It's 14.
Audrey, what did you get?
14.
I don't know what kind of math Latoya is doing. Latoya, please explain to me your arithmetic. You just taught me something new.
No, because I don't know what I did.
I don't either.
Anyway,
So that would be
it's D.
10.
minus 10, Audrey.
Oh, minus 10. Okay, right,
Minus 10, right? Because 2
Okay.
So it's a minus.
and a minus 3 and a minus 9 is a
Yeah.
minus 12. And a
But Miss
Plus?
Barbara, you have 12 years, you have 2, you have plus, yes, on the parentheses. So what you do with it?
what do you mean I have
Plus
plus?
is 2 plus minus 3.
A plus and a minus gives you a minus.
Oh, you do the sign. You
A
you
plus
multiply the
and
sign.
minus give you, that's right. That gives you a
Oh,
minus.
shucks, I
Latoya.
forgot. You
I
have
know
to
you
multiply
forgot
the sign.
something. I know you forgot
Oh,
something. So your
crap.
answer is a minus 10. Answer,
Yeah, minus 10 first pop up, but I was like, I changed my answer.
answer A. That's it. Answer A.
I gotta work on these because I
Okay.
forgot it did the sign is outside the parentheses, so you have to multiply the sign.
That's it. Plus times minus give minus. And here you got minus 3 times minus 3 is a plus 9. There again, plus times minus gives minus. Answer A.
I gotta go get my sign board, my sign
Yeah,
method.
go back to your signs. Okay, so I'll send you homework on what you requested for you to work on, okay? Any questions on anything?
Yeah, some things like these. Something like these I was saying.
Yeah, the
Yeah.
substitution. Yeah, that's
Yeah.
what the other one is, substitution. Any
Wow.
questions on anything we went over? Audrey, I hope it's clear to you and Latoya. You had
I
said
want stuff
you,
to my brain here right now, but then they put in these books, I don't want to take it when you're there.
Math is a
it.
thing where you gotta study every day. Else
Huh?
you won't remember it. Math is a thing where you gotta, it's like
Yeah,
reading.
you gotta be
You gotta
consistent.
read every
You gotta
day.
be consistent. You gotta be consistent with it. Because
Yeah,
when I
if you
done,
if
you
you
know,
take
Bible
up math
study,
once a week, you ain't gonna register.
yeah, because when I done, you know, you're gonna do Bible study. That we're gonna be registering in my mind the whole week.